In problem 3, we are given 3 quadratic functions that actually all represent the same exact quadratic. They're just written in different forms. So in other words, if we graphed these, they would all give us the same exact graph. Now the first part of the problem asks us to identify which form is which. If we look at the first example here, we can see that there are no parentheses in it, everything is fully expanded, and it's written in our usual ax squared plus bx plus c format. That makes this standard form. The next example is written as something times something else, though those somethings are called factors, and that makes this factored form. And the third example here is written where we have something squared and then plus or minus a constant term at the end. This one is vertex form, the only one left. Now we're going to do part B and C together here, which is essentially we want to explain why is each form useful. In other words, what is it really good at finding? And then we're just going to go ahead and find that thing. So standard form is really good at finding the y-intercept. The reason for this is that the y-intercept always has an x coordinate of 0, and if you plug in 0 for x into this equation, all you're left with is the number at the end. So that makes our y-intercept here 0, 8. Factored form is really good at finding the x-intercepts. Now the x-intercepts are what make our equation equal 0 as the output. So in other words, we need to find what x value will give us 0 as an answer for y. Well, the reason factored form is so good at this is that if I can make one of these factors equal 0, then I don't care what the other one equals, because 0 times anything will still be 0. So I notice if I plug in -2 here, that will make x plus 2 equal 0, which means that one of my x-intercepts is -2, 0. The other x-intercept is just, well, what makes the other factor equal 0. In this case, if I plug in -4, I would get out 0, which means that my other x-intercept is -4, 0. Vertex form, the name kind of gives it away. This one's really good at finding the vertex. Now to find the vertex, all we have to do is look at the equation itself. The x coordinate is always right here, except it's always the opposite of what's shown. And the y coordinate is always right here. And it is an exact match for what is shown. So our vertex in this case is going to be -3, because we had a +3 there, -1. And now we have figured out which form is which, we have figured out what they are good at finding, and we have found those pieces of this quadratic.